Hola amigos, welcome to this new Unreal Shader tutorial. In today's video we will make this cool post-process material effect inspired by the Spiderverse movies. Especially on the second one, there are different art styles for a lot of the characters and many of them are inspired by the artists that have worked on their comic book versions. And I think I have some ideas for how to make something like the watercolors of Gwen's universe or the collage effect of Spider-Punk, but I wanted to start with the easiest one, so I picked Miles as the effect to replicate first. I found some artwork, let me pull it up, that we can use to take a look at this. Obviously the character design and the textures play a huge role here, but if we focus on the effects that could be done in post-process, we have, I think, two main bits. We have these 45-degree angle lines on the shadowed areas, and we have a halftone pattern on the highlights. What else? The lines have very similar thickness across the whole thing, but the halftone works more like usual, and we have smaller dots and bigger dots based on the luminance. There's also some specular highlights and some base lighting under the comic book effects, like this is still blue and this is still darker, but I think these are the main parts. In the movie there's also the effects, like there's a lot of motion lines and small pop-ups here and there, but those can be easily done with billboard sprites or particles. And what else? There's also the glitching and distortion when there are portals nearby, but I think we can leave those for another tutorial. And now we can get started. I have a very basic scene here, which is just the default level from the third-person template, plus a couple of color lights and a reflective sphere. This one already comes with a post-process volume, but you can create one if your scene doesn't have it. And make sure that your volume has the infinite extent or unbound option checked, so the camera doesn't have to be inside the volume. And let's create a new material that we can add here. So on the content drawer, I already created it, but let's create a new one and call this one pp_comic tutorial. Before we can add it, we need to change this domain to post-process. So do that and hit apply, and now we can assign it here. So asset reference, and then we can just drag and drop it from the content browser. And our scene goes black. Well, because we don't have anything on the emissive. So let's start with the shadows. So in the shadows we wanted to map some diagonal lines. So let's create those first. Add a texture coordinate. And now if we wanted the lines to be on an arbitrary angle, we could calculate the arctangent of that angle, get the components, and then do a bit of math to get it. But since the lines are going to be on a 45 degrees, we can basically take a bit of a shortcut here. So let's break this into its components and multiply each one of them by a scalar, by a new scalar parameter. And I'm going to call this one line density. And so the full value 1 and multiply. Cool. Now we can subtract one of these values from the other. And if we output this, we're going to have our texture divided in two areas. But it's diagonally, so we're getting close. And to transform this into bands, we can just take the sign of this number. And now they are bands. Perfect. We can even increase the density. Let's say something that is still visible in the video but not too noisy. I don't know, 20. Yeah, okay. But we want our lines to be on the opposite direction. So the easiest way is to add another multiply and multiply our parameter by -1. And now our lines go in the correct direction. Perfect. Let's give this a comment box. Line pattern And let's get the let's see how we can get the shadows of this image, oh sorry, of the original image, so we can map this texture to that. There is a relatively easy way to get the lighting information that we need from the scene using two different scene textures. So let's add one first and set it to post-process input 0. And then we can copy paste this and set the second one to, almost at the bottom, base color as stored in the G buffer. Now, let's connect each one of these to the emissive color first to see what we're working with. So post-process input 0, we hit apply and go back to the viewport, is the final scene color, including our lights, our reflections, the skybox, the rest of the post-process, like the exposure compensation, GI, etc. Cool. And the base color as stored in the G buffer, if we output this, we have just the color of these materials. And you might have noticed, especially on bright or very thin objects, that they seem to vibrate and there's a bit of temporal noise. And this is because when we are applying this post-process effect, the rest of the stack has already passed, so we are kind of discarding or removing the rest of the post-process effects. And to fix that, we just need to change the order in which these are applied. So we can select the material properties and search for blendable, and change the blendable location from after tone mapping to before tone mapping. And now we go back to the scene. Everything is stable and the rest of the post-process is working correctly. Perfect. Now let's see what happens if we divide one of these numbers by the other. So take the post-process input and divide it by the base color. And if we output this, now we have our sphere with less color and the shadow, and seems to be working, but if you look at the sky, it will start blinking and it's almost like a photosensitive warning. So I'm not going to do it, and to fix that we just need to add a saturate node. So add a saturate before you look at the sky, hit apply, save, and we can now safely go back to the scene. And well, we have our shadows, but the lighting color is still affecting this, and it will be hard to work with that. So let's remove the color by adding now a desaturate node. And remember that saturate is not the opposite of desaturate, but just a clamp between 0 and 1. So if we connect that to the emissive, and again hit apply, go back to the viewport, now we have our shadows. Cool. But we want to use them as a mask for our pattern, or for our line pattern, so we should invert this and have the shadows be brighter and the lit areas to be darker. And we could use a 1 minus and just invert these values, but I also want to remap where the shadows, or what is considered a shadow, so we can adjust more precisely where the lines are applied. And for that we are going to use a curve. So go to the content browser, and on the miscellaneous category add a curve, and it has to be the type curve linear color to be used in the material editor. So select that, and let's call this one curve tutorial thresholds. Oh, thresholds. Oh, there we go. And to be able to use this curve, we need what is called a curve atlas, which is just a collection of curves. So right click, and the same miscellaneous category, below curve there's a curve atlas, and we can just copy this name, and I'm going to name this one curve CA, curve atlas, and the same name. And we can now open the atlas, and we just need to, on the gradient curves parameter, add the curve that we just created. So we can even drag it from the browser, and now it's there. So let's open this curve. So right now it's just remapping values that go from 0 to 1 to 0 to 1. So nothing's happening really. And we can make sure that that is true if we go back to our comic tutorial material, and we actually can close the atlas. We don't need that. And let's search for curve and add a curve atlas row parameter node. And this one also threshold. And we can connect the desaturation node to curve time. And if we just connected the output, we are going to get an error because the curve and the atlas are not set. So select the atlas that we created, tutorial thresholds, and the curve that we added. And well, it's back to as it was before, because remember, we are not changing any of these values in the curve. So 0 to 1 is mapped to 0 to 1. Okay, so let's take a look at this. We are only using the red channel, so let's hide the green, blue, and alpha, so it's easier to look at the nodes and change them without selecting the other channels and whatnot. And for now, just invert these values. So 0 goes to 1, and 1, oh, and 1 goes to 0. Now save, go back to the viewport, and there we have it. This is our mask, or shadow mask. All the shadowed areas are brighter, and we can even see the effect of this light, like the inner radius and the outer radius, the second softer light. But if we want to remap this, because right now the lines will be applied to all of this and only be a little bit subtler around this area. So let's say we want to change this and have less of these dark lines. We just need to move the second node to, let's say, half for now. And now our lines will only be applied here and a little bit softer here, and not cover any of the lead area, or just a little bit of a transition here. We can even play with these values and change the nodes to maybe break on both. So we can also use weighted tangents, and we can maybe do something like that. Maybe extend this. And now we have a bit of a bigger transition, but we're still removing the brightest parts. So now that we have our gradient defined, let's multiply this value by our mask, or sorry, by our pattern. So multiply by this sign here, and if we connect it back to the emissive, well, now we have our lines, but only our lines. So first, let's increase this density a little bit. So 100. And yeah, we have our lines, but again, just the lines. So let's fix that. And for that, well, if these are our shadows in some way, the only thing that we need to do, if we have here, if you remember, this is our base color without any lighting, well, the shadows are basically less color. So we can take the color and from that value subtract our shadows, and let's see what happens now. Almost. Now there's something happening, but the areas between these bands are brighter for some reason. Well, that reason is that this range that we are subtracting is not in the 0 to 1 range. So let's fix that, and remember our saturate does exactly that, and we connect it, hit apply, perfect. Now we have our black lines, but the rest isn't affected, which is exactly what we want. And we can take a look and see how it looks on the character. Cool. Yeah, we can even increase the density a little bit if we want more detail. Let's see, 150 maybe. Yeah. Okay, let's give this a comment and let's change this. I'll give this a call as shadow mask and make some room for the next part. We'll work on the highlights next, and much like we did earlier, creating the pattern and then the mask, we'll start by creating a halftone pattern. So yeah, from the texture coordinate, let's add a custom rotator so we can rotate this pattern and add a constant value like 0.2 or maybe 0.16. Yeah. And then increase the density with the scalar parameter. I'll call this halftone density. Density. And just for the preview, let's give it something that we can see. So maybe 50. And now we need to take the decimals. So let's take the fractional part. And that means we have now 50 gradients that go from 0 to 1 a bunch of times. And if we center those by multiplying first by 2 and then subtracting 1, subtract 1, instead of a bunch of 0 to 1 gradients, now we have a bunch of -1 to 1 gradients, which means that we can take the length, and it's a two-dimensional vector, so connect it here. And if we output this just for a moment, we have a bunch of dots rotated not 45 degrees but close. Cool. So let's give this a comment, create comment from selection, and call this halftone pattern. And yeah, that's good. We can now create the mask. And earlier we divided the post-process input 0, which was the final color, by the base color. And now we'll do something similar, but instead we're going to take the final color, and instead subtract the base color. And let's see what happens if I output this. Apply, save. Oh, sorry. There we go. Now we have only our lights. We have a little bit of reflection, and we still have the skybox and the lights and no shadows. Perfect. That's almost it. But for now we just want to create a mask, and that's gonna be easier if we work with a gradient, with a grayscale, sorry. So I'll go back, and now we have our light values. Excellent. So earlier we use this, we use a curve that we created, which is here, to adjust the mask for the shadows. And now we can copy this, paste, and do the same, but instead of using the red channel, we'll use the green channel. And let me hide the red channel, show the green one, and right now we have a 0 to 1 gradient. I'm going to change it back to linear, so it's the default 0 to 1 values, and we output again the green channel. Save, and nothing changes because, much like we did earlier, we are not remapping anything yet. And we can change that, and maybe we don't want to apply the halftone pattern to everything, but just reduce the range a little bit, so we can move this and compress it a little bit, so So I don't know, maybe something like that. Or we can keep the range but change the curves. And the same as we did, we can also change the weighted tangents and increase this so we have a bigger transition. Cool. So let's save this and go back to the material. And this is basically our highlight mask. So we can create a comment here, highlight mask. And now this mask we can apply as a Pantone pattern, or sorry, a halftone pattern. We can use a smooth step function. And I use a custom function to do this step in a different video. You can check that one if you want to use that one, which anti-alias the result using derivatives. But for now, I'm going to keep it simple and use a regular smooth step. And we can do this in a couple of ways. Connect the length to the maximum, this to the minimum, and yeah, keep the value at 0. And let's see what happens if I connect it back to the emissive. Cool. Now we have our lights, our lit areas that are just visible under the halftone pattern, and the size of the circle kind of indicates the intensity of the light. Oh, we can now increase the density a little bit. Oh, 150. Let's see how it looks. Yeah, perfect. So actually I'm going to include this here, and for now we can just multiply this by the final color and see what happens. Cool. Now we have our lights, and because we reduce the range of the gradient, this has just a little bit of the effect, and it's mostly concentrated on the areas that have these very close spotlights or point lights. Perfect. Now, before we move on, let's say that we want this effect to only happen on the character, but we want the shadows to still be applied to the whole image. And we can do that with the stencil buffer. And to use it, make sure that in your project settings, if you search for stencil, your custom depth stencil pass is enabled with stencil, the bottom option. Now you need to go to every object or character that you want the effect to be applied and select any of the meshes or all of the meshes and search for custom, and do two things. One, enable the render custom depth pass, and second, give it a value, and 1 will work for most. If you have at least one object, 1 should be good enough. Now let's see how to use that. I'm going to, for now, just remove this multiply here and add as another the same texture. And let's set this one to custom stencil. And for now, let's connect the color to the emissive output, hit apply, and see what we have. A black scene, but if we hit play, our character, which we enabled the custom pass, is rendered as a white silhouette. Perfect. Now we have a mask. So now let's combine the lighting on the character with the lighting on the rest of the world. So for that we need to invert this value, so 1 minus, and now we have everything by the character in this node. Next we want to multiply that one, and we want also to multiply the base color. Now the rest of the scene, we're going to just multiply it by the lighting information, which, if you remember, is here on this subtract. Now we can make sure that we don't have any negative values by using a maximum between that number and 0, and then multiply, we can multiply this one here and this one here. So now we have just the lighting on the whole scene, but not on the character. Now we need to combine it with the opposite. So here we have just the lighting on the character. So if I manage to get close to that red light, to that light, should be, yeah, there. Perfect. So now we just need to, not this one, this one, multiply again by this, so we also have the color on this one, and now we just need to combine both. So add, and let's see what we have. Apply, save. Cool. And now our character is lit only by this effect, but the rest of the world is lit normally. Now let's give all of these nodes their own comment box. Stencil, masking, and actually something we can do is add another max here if we want to keep some of the original lighting, like maybe 0.075 before this multiply. Okay, hit apply and save. Let's take a look. So now we have some of the regular lighting, and on top of that we have our mask. Oh, let's combine this with our shadows, and for that it's just a matter of adding both together. So add this and this one, and I think we're almost done. Cool. Now we have our shadows. If we get close to the light, we have our highlights. Let's zoom in a little bit. Yeah, this looks pretty cool. One thing we're missing is the specular. So the specular has been basically killed by these shadows because we're taking the white color, or we're applying mostly the white color. So let's fix that, and that should be pretty quickly. Let's see. Let's go here and see between these two. Add another scene texture, and let's take the specular color on this one, and let's add a multiply node so we can tone this effect. Let's say 0.5 for now, and then let's subtract from this, from the base color, let's subtract the specular value, and then hold Control to replace all the connections, and then we need to fix this one because we also dragged it. So let's see what happens now. Now we have more of the reflection, and we can even go back to this value. Let's see, 0.8, and we increase the reflection value. Now it's just a matter of tuning the parameters and playing with these densities. And something else you can do is change the densities, both the lines and the dots, based on camera distance. But I think that for this tutorial I'm gonna probably leave it here and maybe increase this value. And yeah, I think this looks pretty cool. The last thing we can do is maybe go to the post-process volume, and ideally we want to do this as part of our post-process chain manually and control it a bit more. But just to finish the tutorial, I'm going to, if I can find it, go to the chromatic aberration and increase it quite a bit, 3.6, just to get that extra distortion. And that's it for today. An Unreal post-process shader inspired by the Spiderverse movies, made from scratch. I hope you guys enjoyed this tutorial. Please give a like and consider subscribing if you did. See you next time.